This is your video lecture for Chapter 1, Section 3, entitled Elements. We're going to be talking about the periodic table of elements, and we're going to begin talking about how we're going to use it to understand properties of matter and why things behave the way they behave. Some specific learning goals, things that you need to focus on for this particular section. You need to be able to use a periodic table to name elements given their symbols, as well as write the symbols of the elements given their names. So this is what we've been doing in class, practicing with our flashcards. There will be a test just on the element names and symbols. I also want you to be able to describe the arrangement of the periodic table. One of the ways we're going to do that is being able to distinguish between metals, nonmetals, and metalloids, as well as being able to describe why they're positioned on the periodic table as they are. Let's get started. This is the periodic table. This is something that's fairly similar to what you have, what you've colored in class, and you've identified some of the major categories that you can find. On the periodic table, you're going to find all of the elements that exist. This is all of the basic elements, or the pure elements. We've gone over the different categories of matter, things like pure substances and mixtures. These are all of the elements. So on the periodic table, once you're there, you're going to find that the periodic table organizes the elements in a particular way, and a great deal of information about the element can be gathered from its position in the periodic table. For example, you can predict with reasonable certainty the physical and chemical characteristics of the element. You can also predict what other elements a particular element will react with chemically. Also, to give you an if you have an understanding of the organization and the way that the periodic table is planned, you'll be able to obtain some basic information about each of the other known elements. What you guys have been practicing in class with your flashcards are the symbols. All elements have their own unique symbol. It can either be a single capital letter or a capital letter with a lowercase letter. So this is an example of what your test is going to look like. On the test, I will simply have whited out either the element name or the element symbol. I will give you the other, the opposite, and you'll have to fill in the table accordingly. All right, moving into the different categories of elements. We've already identified three basic categories. You have the metals, the nonmetals, and the metalloids. Again, we have the nonmetals mostly to the right side of the periodic table, including hydrogen over here. We have the metalloids making kind of this step ladder look over here, but then the metals make up most of the periodic table and also to the left. Some specific groups, we have the alkali metals over here in group A1, the alkaline earth metals here in A2, moving all the way over to the noble gases. This is group 18, okay, also known as A8, and then the halogens in group 17, sometimes referred to as A7. Just so we don't have a bunch of confusion, we have two different groups of elements here at the bottom of the periodic table. We have the lanthanide series and the actinide series. Again, these are pulled out of the periodic table simply so it won't be too wide. As far as being able to distinguish between metals, nonmetals, and metalloids, we'll need to know some of their properties. Now, metals, a distinguishing characteristic of metals, that they're good conductors of heat and electricity. Metals are shiny. Their luster is a defining characteristic. Metals are ductile, which means that they can be stretched. Okay, they can be pulled and stretched into thin wires. Metals are also malleable. which means that they can be pounded into thin sheets. If I were to hit one with a hammer, it would not shatter, but it would squish and flatten out. A chemical property of metal is its reaction with water, which causes corrosion. You guys have heard of things like rust. Okay, what do you have to have metal exposed to in order for it to rust? Some form of oxygen, a lot of times in the form of water. Okay, get some metal wet and it'll eventually rust. Moving on to nonmetals. Okay, nonmetals are almost the polar opposite of metals. Nonmetals are poor conductors of heat and electricity. Nonmetals are not ductile or malleable, and the nonmetals that we observe as solids are brittle and they break easily. If I were to hit one of these with a hammer, it would shatter into a million pieces. Again, luster is a distinguishing characteristic. Nonmetals are dull. They have a dull look. There's no sheen, no shine. Well, most nonmetals are gases as we observe them in nature. Metalloids. Again, we talked about this in class. Metalloids are metal-like. It's the nature of the word. They're metal-like because they have properties of both metals and nonmetals. They are typically solids, but they can be shiny or dull. So for metalloids, the luster is no longer a distinguishing characteristic by itself. They conduct heat and electricity better than nonmetals, which are non-conductive, but not as well as metals, which are, remember, good conductors. So they're an intermediate there. But they do tend to be ductile and malleable. A key thing here to remember is metalloids truly are an intermediate between metals and nonmetals. Some terms we want to be familiar with. Elements in the periodic table are grouped into families, or sometimes also referred to as groups. Okay, these are the columns. Okay, going up and down, these are referred to as columns. I'm sorry, they are columns. They are sometimes referred to as families or groups. Okay, elements that are in the same family or in the same group have similar properties. Conversely, or perpendicularly, elements are also categorized into periods. Periods are the horizontal rows. Okay, going down the periodic table, you'll be going down different periods. Okay, periods going horizontally. So let's contrast families and periods just real quick. Families are columns, are called groups or families. Elements in each family have similar properties, but they're not the exact same. We saw in class a video recording the reactivity of alkali metals with water. Notice that they all did the same thing. They generated hydrogen gas, and it was a very violent exothermic reaction. However, the extent of the violence varied as you went down the family. So they have similar properties, but they're not identical. For example, lithium, sodium, potassium are all members of group A1, or main group 1. Also, they are all soft, white, and shiny. All members in a family have the same number of valence electrons, which is something that we will cover very soon. For a period, each horizontal row of elements is called a period. The elements in a period are not alike in properties. Okay, the situation in which you would find elements sharing properties would be a group or a family. That is not the case in a period. The properties change greatly, in fact, across any particular period, across a horizontal row. The first element in a period is always an extremely reactive solid. The last element in a period is always an inactive gas, because we'll always start on the left, at the beginning of the period, with an alkali metal, which is the most reactive, group of metals. And then we'll end on the far right with the noble gases, which is a very non-reactive gas. let's look at a few families. So we have hydrogen by itself. Okay, it is in group 1A, however it's a nonmetal. Move over one, we have the alkaline earth metals. Onto the transition metals. Here we have main group 3 or A3, main group 4 or A4, group 5 or main group 5, A5, main group 6, and on the halogens in main group 7, and then the noble gases in main group 8. And then we have the lanthanide and actinide series down here at the bottom. I do want to mention the halogen family in particular. This will be one of the groups that you will need to know on the test. The elements in this family, they're fluorine, chlorine, bromine, iodine, and acetine. Okay, halogens have 7 valence electrons, which explains why they are the most reactive nonmetals. And because they're the most reactive nonmetals, they're never found in nature by themselves. Okay, halogen atoms only need to gain 1 electron to fill their outermost energy shell, and they react with alkali metals to form salts. Last group I want to cover in this particular lecture, the noble gases. Okay, the far right group 18, sometimes referred to as A8. The noble gases. Noble gases are colorless gases. They're extremely unreactive. It doesn't mean they do absolutely nothing. They just are an extreme example of non-reactivity. One important property of the noble gases is their inactivity. That's why we call them noble. They're inactive because their outermost energy level is full. Because they don't readily combine with other elements to form compounds, noble gases are called inert. Note, we have to say they don't readily combine with other elements. If they do, it's just that it's not very common and some special conditions are necessary. The family of the noble gases is going to include helium, neon, argon, krypton, and xenon, and radon. All the noble gases are found in small amounts in the Earth's atmosphere. Let's recap our goals, see how we're doing so far between this video lecture and your reading as well as your assignments. I want you to be able to use the periodic table to name elements given their symbols, as well as being able to write the symbols of the elements given their names. I want you to be able to describe the arrangement of the periodic table. Again, that would be identifying the group numbers, okay, either using group 1, group 2, group 3, group 4, and on up until group 18, or group A1, group A2, group B3, in that particular style. Identifying each one as alkali metal, alkaline earth metal, transition metal, halogen, or noble gas. So that's what that goal is referring to. As well as I want you to be able to list the characteristics that distinguish metals, nonmetals, and metalloids, because you remember these are the 3 more broad categories. We talked about luster, talked about conductivity of heat and electricity. Malleability and ductility are going to be some of the key characteristics that you're going to need to refer to both on the test and in a quick write coming up in class. So I hope this made sense to you. If it did not, be sure to bring those questions to class. All right? I'll see you next period.